Hey guys, let's try this one more time, hopefully the last time for a while. We will take notes and have an assignment similar to yesterday. However, I obviously haven't been at school, so I haven't been able to print the notes for you. So you will have to take them on your own paper today. So pause it when necessary if you're choosing to write down the original function. Otherwise, at minimum, write what I write. Okay, let's start. I was looking at your Delta Math from yesterday. The people who did it did a fabulous job, but there are lots of you who didn't do it. So let's start where you pause the video and you try a couple problems from yesterday where we were doing composition of functions. So for this first function, again, I'm back to my stylist with very bad handwriting. Remember, we established that composition of functions as indicated by this open circle, right? It's not a multiplication dot, but it's telling me to plug 4 into f, and then that answer gets plugged into the g function for our final output. So if I plug 4 into the f function, and I'm very careful with my order of operations, well, I see I'm going to be taking 3 times 4 squared, so 3 times 16. That minus 4 plus 4 is just going to cancel, so 3 times 16 should have given us 48. That was by doing f of 4. Now I still have to plug 48 into the g function. So I would take 2 times 48 minus 1 to get 96 minus 1. So my final answer from this composition of functions was 95. How about if I do f of g of negative 1? Well, again, I like to rewrite it so that I can kind of think about parentheses and work inside out. So I'm starting on the inside, plugging in negative 1 into the g function, and that would give me negative 3. Now that answer, I'll plug into the f function. So that'll become 3 times negative 3 squared minus a negative 3 plus 4. So as long as we're careful with our signs and order of operations, that becomes 3 times positive 9. This minus a negative becomes plus 3 and then plus 4. So what's that? 27 plus 3 is 30 plus 4, so 34. So there's a quick recap of composition of functions that we went over yesterday. Now, of course, if you didn't genuinely watch yesterday's video, or if you were just absent or missed it for some reason, I would suggest going back and doing that first, because today is going to build off of yesterday. So yesterday we introduced the idea of composition of functions. Today we're going to continue to combine functions by composition, or compose functions, but we're going to be doing it algebraically. So just like we did with our operations, sometimes we have a number to plug in for x, and sometimes we just talk more abstractly or generally about the function in terms of x. So our answers today are going to look much more algebraic than numeric, but the idea is the same. So again, I'm sorry since I wasn't able to print your notes. If you want to pause and actually write down these two functions, go for it. Otherwise, let's notice the big difference today is my input is just x, right? So I don't have a number to actually plug in. The concept is the same though. I'm going to take h of x, so I don't really have anything to plug in, and I'm going to plug that into g. So another way of thinking about it, I'm going to take h of x, or I can rewrite it like I rewrote them yesterday. H of x, I just know is this whole expression, right? That is the function h in terms of x. Well, I'm taking all of that. I don't have a number to plug in for those x's, so I'm just taking that expression as is, and I'm plugging that into the g function. So maybe it seems easier, or maybe it looks too easy. But I'm going to take this whole h of x function, plug that into the g function, so that x squared plus 2x plus 5 plus 7, and then I can combine like terms. And that's about it, right? So it's kind of like what we saw on Tuesday when we just had x as our input. we just end up with an expression in terms of x as our output. So here's our new function where I've composed by plugging the h function into the g function. Now, maybe that one was too easy. Don't worry, they can get a little bit harder. Let's go the other way. So for the second problem, it's asking for h of g of x. So if I can erase what I had kind of done up here, I need to go in the opposite order, right? So this time I need to take, right, I'm going to start with the g of x function, and I'm going to plug that, so this whole function, into h. Well, that's going to have to get plugged in here, of course, and here. Just like with a number, we would plug that number anywhere for x. Well, I have to plug this whole expression anywhere for x. So I'm going to plug in, square it, plus 2 times plug it in, plus 5. And what am I plugging in? Again, I'm not plugging in a number. I'm just plugging in this whole expression, or the function, for g of x, which is x plus 7. Now, Larry said, don't worry, they will get a little bit harder. I don't know if it's harder, but it's definitely more work, right? Because remember, we can't get lazy. Here, x plus 7 squared, I would write that quantity twice and remind you about our good old-fashioned FOIL, right? Or double distributing. X times x is x squared plus 7 times x plus another 7 times x plus 7 times 7. So here we are again, right, in Algebra 2, but we're reviewing all these Algebra 1 skills where I can distribute, combine like terms, and that's all just by taking the quantity squared. Now I still have to distribute this 2, so that became 2x plus 14, and then drop down that plus 5 on the end. Whew. Not pretty with my stylus again, so sorry. Now let's combine like terms. I just have 1x squared. I have 14 plus 2 x's, so 16x. 49 plus 14 plus 5, I believe would give us 68 for our constant. So a little more work to it in that direction, but there's composing functions algebraically. All right, again, since you're taking your own notes, if you want to pause and write down our two new functions, here's our f function and here's our g function. Let's start with f of g, nope, can't read, with a g of f of x. So let's start by taking the f function, so taking all of this and plugging it into the g function. Okay, that one looks like it's going to be the easier one, right? Because all I have to do is take 2 times, plug it in, and then subtract 1. I'm plugging in this trinomial. Squeeze that in there. And so really I just need to distribute, combine, and I'll be done. So I'll distribute to get 6x squared minus 2x. That was a 4, so 2 times 4 is 8. Drop down the minus 1, and then I know 8 minus 1 will give me a 7 on the end of this trinomial. Right? So that was definitely the easier direction. What about instead if we do f of g of x? That's going to be the fun direction. See if you understand why. Do you know what we're plugging in where? Here's why. I'm going to plug g of x, that binomial here and here. So I get to plug it in 2 spots and do a whole lot of algebra, right? So once we understand the concept, hopefully we realize, okay, I get the concept. It's just a lot of algebra, but essentially after we get the concept down, it becomes review. So I plug in. My first step is always exponents, right? Think about PEMDAS. So I'm going to take this quantity squared, 2x minus 1, so let me write it twice, and start double distributing. So that'll become 4x squared minus 2x again, plus 1. So there's our classic FOIL process we learned way back when in Algebra 1. That's just by doing the exponents. Now remember, I still need to distribute the 3 and bring down everything else. Okay, so now let's move on to distributing. So let me distribute the 3 to get 12x squared minus 12x plus 3. Right, when I distribute the negative here, so minus 2x plus 2, drop down the 4. All right, I've got all my terms. Now I just need to combine the like ones. So 12x squared is the only term with an x squared. I think I have a negative 14x, and then 3 plus 2 plus 4 would give me a plus 9 on the end. Oh, why was that a 2? I'm sorry. Excuse my math. This, I'm sorry, I just distributed a negative times a negative, so that became a plus 1. At least I caught that, hopefully in time. I haven't made other mistakes yet, but I'm recording these videos awfully late, so if I make mistakes, I apologize. Let's see now. Okay, now combine those like terms. I think we have 8, right, as our constant. All right, so I wish we were together so I could see how you're doing, but instead we'll just kind of pause the video and let this be your moment to reflect and try without me. Here are 2 problems. See if you can first notice the big difference between them and try each on your own. So of course the difference here is one has this x, so it's going to be more algebraic, and the other has an input of 2, so that's more numeric, right? So this first one in blue here is what we've been doing today, where we're just taking the function in terms of x and plugging it into the other function. So I'm going to take this f of x function and plug into g. Yay, you got to plug in twice and practice all that Algebra 1 fun, right? So you were taking 3, plugged in for x, and plugged in for x again. We were plugging in negative 5x plus 1 as our inputs. So if you didn't believe me yet, I bet you do now, that this is just a whole lot of Algebra 1 review. So let's start with the exponent again. Squaring something means I'll write that quantity twice and I'll practice foiling. So this becomes positive 25x squared minus 5x minus 5x again and plus 1. Combine those like terms to get 25x squared minus 10x plus 1, and that's just from double distributing. Now I still have to distribute the 3 and distribute the 2 to this quantity, and then we'll combine our like terms. So that gave us 75x squared minus 30x plus 3 when you distribute. Boom, boom, boom. And then distribute again, so negative 2x plus 10x, plus 2. And combine like terms. So starting with our highest term, which is 75x squared, going to our negative 40x, and then ending with 3 plus 2. All right, so that's recapping what we did today. Composing functions where we just have an x as our input, so we get lots of practice with those Algebra 1 skills and get an algebraic output. And then the second problem reviewed yesterday's idea of same thing, composing functions, but with the numeric input. So if I have a 2 to plug into the g function, I would start with subbing in the 2 and evaluating. I still do order of operations, right? So it's still 2 squared, so that gives me 4 first, and then 3 times 4, and I would get an output of 16. That's just from plugging 2 into the g function. Then we use that output, and it becomes the input now into the f function. So now 16 I'll plug into the f function to get negative 80 plus 1, so negative 79. And there's our recap from today and yesterday with this assignment for today.